Hi, this is Mrs. Marita. Welcome to AP Stats, Lesson 1.3c. Our learning target for today is number 6. Using box plots and numerical summaries to compare distributions of quantitative data. So let's jump into example 4. The following data show the number of contacts a sample of high school students had in their cell phones. Do the data give convincing evidence that one gender has more contacts than the other? So the big question we want to answer is that last one. Do the data give convincing evidence that one gender has more contacts than the other? But we're going to practice a couple of the tools we've learned this chapter since this is our last example for chapter 1. To help us organize our response, we're going to use one of our stats and complete the table below. So the first thing we need to do is enter our data. Go ahead and go into stat and enter. I entered my male data in list 1 and my female data in list 2. So go ahead and pause the video and take a moment if you need to get your data entered. Next, we're going to use one of our stats to get the statistics to complete your table. So we're going to go back up to stat, but now we'll go to calc and one of our stats. So we're going to find these separately. So list 1, that's my male data. So enter, enter, and take a moment. You can copy these down. We have our mean, our sample mean here, and our sample standard deviation. Be careful, we're always going to use the S, our sample standard deviation, not the sigma. The sigma, if you recall, that's the notation for your population standard deviation, and that's never what we're going to have in our stats class. We'll always be working with a sample. Then you'll scroll down to get the rest of your 5-number summary. Next, we're going to do the same for the female data. So I'll quit out, stat, over to calc, and notice there is a 2var stats. That's not what we want. We have 2 separate sets of data, so we just need to complete one variable statistic for each. The 2var stats is when we have variables that are related to each other, but we do need to change our list to list 2. There we go, so second 2, and then calculate. Again, go ahead and copy the statistics down to complete the table. We're using our sample mean, our sample standard deviation, n is our sample size, and then as you scroll, you get your 5-number summary. So take a moment and make sure you've got all of the right statistics filled out for your male and female data, and then we're going to move on to construct parallel box plots. So to graph our parallel box plots with our calculator, we're going to go into second, stat plot, and plot 1 we'll use for the male data, plot 2 we'll use for the female data. So I'll hit enter. Make sure to turn your plot on if you've recently reset your calculator and scroll over to the box plot that includes outliers. We're not sure yet if there are outliers. We haven't used our 1.5 times the IQR rule, but this will be a shortcut for you if you already have the data in your calculator. If they don't ask you to justify or check for outliers, this will be a quick way that we can see, are there any outliers, yes or no. Make sure to hit enter. List 1, yep, that's for my male data. And then instead of hitting zoom 9, we're going to do parallel box plots. So I'm going to scroll up and go over to plot 2. We're going to have 2 plots going at once. Make sure to turn that one on and scroll over to your box plot. There we go, with the outliers. And then double check, yep, this is our list 2. That's what we want for the female data. You could always change it if you had your data in another list. Last, now we're ready to see the box plot. We're going to hit, here we go, zoom and 9. One of the great things about box plots is you never have to adjust your window. And just like before, we know the male data is right here. That was our list 1. Female is down below, and we can use our trace feature. It'll always start with plot 1 at the median, and when you want to graph this in your notes, you'll just scroll over. This should be the 5-number summary we already found, so no surprise there, but it might help you with your spacing. And then to get to the female box plot, you're just going to scroll down, and then you can arrow over. Again, you can ignore the scale and the axes here. That's not important, and again, some of your calculators might not even do that. So take a moment and copy this into your notes. Also notice we have no outliers, no high or low outliers. So when you're comparing 2 sets of data with box plots, we need to plot them on the same axis with the same scale. So we're going to plot parallel box plots. one above the other. Just a reminder, when we're making our box plots by hand, start with your box, plot your Q1, median, Q3, then your whiskers. You can also try this with the calculator as reviewed in the previous video, and you'll notice with the calculator that there are no outliers. So I didn't even check for outliers by hand. I just did the box plots on my calculator, saw that there were no outliers, and moved on. Make sure to label the two box plots, your male and female box plot, and of course label your axis, number of cases. The last part of this example is our description. So we're going to describe and compare using CVS, so our center, variability, and shape. Notice there is no outliers, but always make sure to include context. We're also going to answer that final question. Do the data give convincing evidence that one gender has more contacts than the other? So for the first part, the describe and compare. The shape of the distribution of number of contacts in a student's phone is skewed to the right for males and approximately symmetric for females. Neither distribution has outliers. The centers, both mean and median, are higher for the female students, and the male students have wider variability. And make sure that you can go through and identify where the centers, variability, shape, and outliers have been discussed. Notice we also have complete context with the variable of study, number of contacts in the student's phone, and also the individuals we are studying, males and females. So to answer their question, is there evidence that one gender has more contacts than the other? We can say, although the maximum number of contacts from the male data is larger than the max from the female data, we could conclude that the females tend to have more contacts. This is because both the median and the mean number of contacts for females is larger than those for the males, so females tend to have more contacts.